Hi guys, this is the second video of probability trees where we'll be looking at some awkward questions. So you can see here in this question, there are 4 sandwiches that are egg, 5 sandwiches that are cheese, and 2 ham sandwiches. And we're asked to find out the probability that Erin takes 2 different types of sandwich. So in the first video, you would have seen us do 2 probability trees with 2 stages. Sorry, 2 options. Here you can see there are 3. So we can have an egg, cheese, or a ham. Having got an egg, cheese, or ham, we could get egg, cheese, or ham. And so this is where it gets awkward. And yeah, a bit of an effort with a tree, isn't it? So work out probably that she takes 2 different types of sandwich. So the probability that she gets different sandwiches will be 1 minus the probability that they're the same. I think you'd agree with that. Well, this is where my first bit of advice would come. In an exam, only use a tree diagram if you're given one. Yeah. If you're not given a tree diagram, you'll see that it's probably easier to not use one, because the ways to get the same sandwich would be, we could have an egg, egg, a cheese, cheese, or a ham, ham. So the probability that the first sandwich is egg is 4 out of 11. Having taken an egg sandwich, there'll be 1 less sandwich there, which will be 10, 3 of which will be egg. So yeah, we could have filled it in on the tree, but personally, I don't think it's a necessity. So for a cheese sandwich, we've got 5 out of 11. And the probability the next one is also cheese. There'll be 1 less sandwich and 1 less cheese sandwich. So we could have filled it in, but again, not a necessity. And ham, 2 out of 11. We take 1 out, we have 1 less. So we could have done that, but obviously, if you prefer to do the tree, then do. So if you did the tree, you would have figured out egg, egg, cheese, cheese, and ham, ham, which we've done here. So we have 12 out of 110, 20 out of 110, and 2 out of 110. So the probability they're different will be 1 minus 12 plus 20 plus 2 out of 110, which is 1 minus 34 over 110, which is 66.76 out of 110. Yeah, which we could write as a decimal. It's not a necessity though. Yeah, if it's in an exam, it says, right, leave your answer to 3 significant figures, then you'd know to leave it as a decimal. So we've got that. So yes, we could have filled in the tree, but was it a must would be the question that I would ask you. Yeah, blah, 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 blah. So let's have a look at one more. So work out probably that the 2 biscuits are not the same. So again, we've got Caroline takes around 2 biscuits from the tin, work out probably they're not the same. Well, let's figure out the probabilities of them being the same first. So you could get 2 plain biscuits. There are 12 plain biscuits, and there are a total of 20 in the tin. Yeah, 12 plus 5 is 17, plus 3 is 20. If we take a biscuit out, there'll be 1 less biscuit and 1 less plain biscuit. 2 chocolates, we have 5 out of 20. If we take a biscuit out, we have 19 biscuits, 4 of which are chocolate. And ginger, we have 20 biscuits, 3 are ginger. If we take that out, there's one less biscuit, one less ginger biscuit. So if we just do that, we can multiply to figure out what the probabilities are. Yeah. Now, if we add these up, so the probability they're the same will be 132 out of 380 plus 20 out of 380 plus 6 out of 380, which is 158 out of 380 is the probability they're the same. So how do we figure out the probability they're different? Exactly. We do 1 minus that answer. And that will give us 222 out of 380. So, which you could write as a decimal, is up to you. So I hope that makes sense. I've labelled this tree diagram questions, more awkward, but in the end, we haven't used tree diagrams. If you want to use a tree diagram, then do. But in this sort of thing, it's a logic question. You just have to think it through, and you can see what I've laid out is a straightforward process to answer the questions. See you soon.